Hey team, we're going to just go over another example. All right. And this one, we're not going to have the answers up there at the top. All right. So, okay, looking, I know my Q1 is negative 6 millicoulombs, which is 6 times 10 to the negative 6 coulombs. And my charge 2 is 8 millicoulombs. That's 8 times 10 to the negative 6 coulombs. My distance, if you look here, my distance is how far apart they are. That's equal to 2 centimeters. And converting that to meters, it's 100 meters per centimeter, so that's 0.02 meters. My K is always 9 times 10 to the ninth newtons, meters squared, coulombs over coulombs squared. All right? So that's my info. I know that's kind of hard to see from a distance, but there's my charge 1, there's my charge 2, all right? And there it is bigger, all right? Now my formula is force is K Q1 times Q2 over R squared, and this sometimes is written as, you could write it like this, K Q1 Q2 over D squared. I mean, it's all the same thing, whatever makes sense to you. Now I got to substitute in my charges, going to go there, my distance is going to go there, and my K is going to go there. All right? When I write it out, it's going to look like F equals 9.0 times 10 to the ninth newtons meters squared over coulomb squared times negative 6 times 10 to the negative 6th, 8 times 10 to the negative 6. These are coulombs all over 0.02 m squared. And that should be a lowercase m. Silly me. Now, this may seem like a lot of gobbledygook, but it's not as hard as you think. You can take care of your exponents and your numbers individually. You can do it on a calculator. I'm going to do it in my head or mentally. With exponents, you just add them up. Since it's multiplication, you add them. So 9 plus negative 6 plus negative 6. All right? So I'm afraid. So here I bring these things together, the exponents. All right? So 9, negative 6, and negative 6. That's equal to negative 3. All right? Now, these numbers, the numbers that, all right, 6 times 8 or 9 times 8 times 6, negative 6. So it's going to be negative something. It's going to be negative 432, actually. And the reason I know that is 6 times 8 is 48. And then I got to multiply that by 9. All right? So to multiply a number like this, just multiply these numbers, 40 times 9 and 8 times 9, and add them. So 40 times 9 is 3,600, 360. 72, and I add that up, I get negative 432. All right? Now, once again, you can use a handy-dandy calculator. I like doing it in my head. The coulombs are going to cancel, right? And I'm left with newtons times meters squared, and I get 0.02 m squared. All right? Now, 0.02, how do I square that? Well, to square a decimal, the thing to do is just, hey, make it not a decimal. So what's 2 times 2? We all know that is 4. And then how many spots did I move the decimal? 1, 2, 3, 4. So that means I'd move it 1, 2, 1, 2, 3, 4. So my answer is negative 432 times 10 to the third, and this would be meters squared, newtons times meters squared, all over, all right? Oh, that's what that equals. And now the meters are going to cancel, and I'm left with newtons in my units. All right? Now, my fine students. So I've got this thing. Now, how do I do? Oh, this is a -3, not a 3. That's important. -3. Don't forget those negatives. Now, how do I simplify this? Well, you can use a calculator. All right? You can also just do some simple things about exponents. I said simple. That doesn't necessarily mean it's easy. All right? So this is -432 times 10 to the -3rd all over. This number on the bottom is 4 times 10 to the -4th. 3, 4. And with exponents, when you divide, you subtract. So -3 minus -4 is equal to +1. So this becomes -432 all over 4 times, all right? Now we would divide 432 by 4. 432 by 4, how many times does 4 go into 400? It goes in there 100 times. How many times does 4 go into 32? 8 times. So it's -108 times 10 to the 1 newtons. This 10 to the 1 is 10. So my answer is that. The negative here means attractive. Boom, nailed it. Okay, hope that helps. Bye.